Let me ask you something. When you order something online, what part of that journey do you think costs the most? The cross-country trucking? The warehouse processing? The ocean freight from overseas? None of the above. It is the last mile. That final stretch from a local distribution center to your front door. And it is not even close. According to research from Capgemini, 53% of the total shipping cost of a package is consumed by that last mile alone. More than half. Think about that for a second. All the infrastructure, the ships, the planes, the trucks moving goods across continents, and the single most expensive piece is a van driving 10 miles to your neighborhood. Now multiply that across an entire logistics operation. The American Transportation Research Institute estimates that $10.1 billion is wasted every single year in North America on inefficient routing alone. Not bad logistics strategy, not poor warehouse management, just routes that are not optimized. And here's where it gets really interesting. MIT FreightLab found that roughly 30% of all delivery miles driven today are suboptimal. That means nearly a third of every mile your delivery fleet drives could be done better, faster, or eliminated entirely. So why is this so hard to fix? Picture a typical delivery driver's day. They have somewhere between 100 and 150 stops. Each stop has a delivery window. Some customers are residential, some are commercial with loading docks. Traffic patterns shift by the hour. Weather changes. A customer is not home. And now you have a failed delivery that costs you $17.20 on average. And failed deliveries are not rare. Industry data shows failure rates between 8 and 12%. Meanwhile, your customers have been trained by the market to expect speed. 67% of consumers now expect same-day or next-day delivery. That expectation is not going away. It is only accelerating. So you have this perfect storm. The most expensive segment of your supply chain is also the most chaotic, the most variable, and the one your customers judge you on most harshly. Static routing simply cannot handle this. Someone plans routes the night before based on tomorrow's orders. The driver gets a list and heads out. But the moment that driver hits the road, reality diverges from the plan. Traffic builds up. A delivery window shifts. A priority order comes in at 9:30 that was not there at 6. The static plan is already obsolete. Every get decision costs money. An extra left turn here. A backtrack there. Sitting in traffic because the route did not account for a school zone at 3:15 in the afternoon. These inefficiencies compound across every driver, every day, every route. And this is exactly why the last mile represents the single biggest return on investment opportunity in all of logistics. If you can shave even 15 to 20% off last mile costs, you are talking about transformative savings at scale. The companies that figure this out do not just save money. They deliver faster, pollute less, and keep their drivers happier. The question is how. And the answer is not more drivers or bigger trucks. The answer is math. Specifically, the kind of math that only artificial intelligence can do at the speed and scale that modern logistics demands. Let me show you exactly how that works. To understand how route optimization actually works, you first need to appreciate just how complex the problem really is. Let us say you have 15 stops to make. Seems simple enough, right? Just find the best order to visit them. But mathematically, there are over 1,300,000,000,000 possible route combinations for just 15 stops. That is not a typo. 15 stops. Over 1,000,000,000,000 possible sequences. This is known as the Traveling Salesman Problem, and it is one of the most famous unsolved problems in computer science. As you add more stops, the number of possible routes does not just grow. It explodes exponentially. By the time you reach 25 stops, the possible combinations exceed the number of atoms in the observable universe. No human being can solve this optimally. And brute force computing cannot either, at least not in any reasonable time frame. So how does modern route optimization handle it? The answer lies in heuristic and meta-heuristic algorithms. These do not try to find the perfect solution. They find an exceptionally good one, fast. Genetic algorithms, for example, mimic biological evolution. They start with a population of possible routes, test their fitness, breed the best ones together, introduce mutations, and evolve toward optimal solutions over thousands of generations. All in under a second. Modern AI-powered route optimization engines can solve a 200-stop problem in less than 1 second. That is not theoretical. That is production-grade performance happening in dispatch centers right now. But here is what separates real route optimization from a basic GPS. It is not just about distance. A truly intelligent system optimizes across multiple constraints simultaneously. First, time windows. Customer A needs delivery between 9 and 11 in the morning. Customer B is a restaurant that only accepts deliveries before the lunch rush. Customer C is a business that closes at 5. The system has to respect every single one of these windows while still minimizing total drive time. Second, vehicle capacity. Your truck can carry 4,000 pounds or 1,200 cubic feet. The system needs to ensure you do not overload a vehicle on the front end of a route, and it needs to sequence the loading so that the first delivery is the last item loaded. Third, driver hours. Hours of service regulations mean your drivers have hard limits on how long they can be on the road. The system accounts for mandatory breaks, shift starts and ends, and overtime thresholds. Fourth, fuel efficiency. Left turns across traffic burn more fuel and cause more accidents than right turns. Elevation changes impact fuel consumption. Idle time and traffic wastes diesel. A good optimizer factors all of this in. Fifth, priority and service levels. Some packages are overnight express. Some are standard ground. The algorithm weights these differently and ensures premium shipments get priority sequencing. And here is where it gets really powerful. Dynamic rerouting. The best systems do not just plan a route in the morning and call it done. They continuously re-optimize throughout the day. A new priority order comes in at 10:30. A driver reports a road closure. Traffic data shows a 40-minute backup on the interstate. The system instantly recalculates, pushes updated routes to drivers in real time, and even reassigns stops between drivers if that produces a better outcome. This is possible because these platforms integrate with live telematics data. They know where every vehicle is, how fast it is moving, how much capacity it has left, and what its current delivery status is. The algorithm treats the entire fleet as one interconnected system, not a collection of individual routes. That is the fundamental shift. You are not optimizing one driver's day. You are optimizing the entire network in real time, every minute, across every vehicle. And when you do that, the results are not incremental. They are transformational. So what happens when companies actually deploy intelligent route optimization? The numbers speak for themselves. Across the industry, organizations implementing AI-driven route optimization consistently report fuel cost reductions between 20 and 30%. That is not a marginal improvement. For a fleet burning through hundreds of thousands of dollars in diesel every month, a 25% reduction changes the entire cost structure of the business. But fuel savings are just the beginning. The real leverage is in productivity. Companies are seeing 40% more deliveries per driver per day. Read that again. The same driver, the same truck, the same number of working hours, completing 40% more stops. That means you either need fewer drivers to handle the same volume, or your existing fleet can absorb significant growth without adding headcount. For a fleet of 100 vehicles, the combined savings from fuel reduction, increased productivity, reduced overtime, and fewer failed deliveries typically add up to approximately $1 million per year. And that scales linearly. 200 vehicles, 2 million. 500 vehicles, 5 million. The math is straightforward and it is repeatable. Now let us talk about something that does not always make the spreadsheets, but absolutely matters. Driver satisfaction. Route optimization does not just make routes shorter. It makes them smarter. Drivers are not fighting traffic. They are not backtracking across town. They are not dealing with impossible time windows that force them to rush. When you give a driver a route that actually makes sense, that respects their break times, that does not send them into gridlock at 5 in the afternoon, they notice. Companies using intelligent routing report driver turnover reductions between 18 and 25%. In an industry where the average annual turnover rate for long-haul drivers exceeds 90%, keeping your drivers even marginally longer saves enormous recruiting and training costs. And experienced drivers make fewer mistakes, have fewer accidents, and deliver better customer service. Speaking of customer service, let us talk about delivery accuracy. Modern route optimization platforms can predict estimated arrival times within a 15-minute window and communicate that to your customers proactively. That text message that says your delivery will arrive between 2:15 and 2:30 is not a guess. It is a calculation based on real-time traffic, the driver's current position, remaining stops, and historical delivery time at that specific address. That level of accuracy transforms the customer experience. Failed delivery rates plummet because customers know exactly when to be available. First attempt delivery success goes up, and customer satisfaction scores follow. There is also the sustainability angle, and it is becoming a competitive differentiator. Optimized routes produce roughly 15% less carbon emissions. For companies reporting on environmental metrics, that is a headline number. It is also increasingly a requirement for enterprise contracts. Large retailers and manufacturers now require their logistics partners to demonstrate measurable sustainability practices. Route optimization delivers that with hard data. If you are running a logistics operation and you have not implemented intelligent route optimization, you are leaving money on the road. Literally. This is exactly the kind of problem that CerebroChain's logistics hemisphere was built to solve. Real-time route optimization, dynamic fleet management, and predictive analytics all working together in one unified platform, not bolted on modules. Native intelligence from the ground up. If you want to see how this works with your actual data, head over to CerebroChain.com and explore what the logistics hemisphere can do for your operation. If this breakdown helped you understand route optimization better, hit that subscribe button. We are building a library of deep dives into the technology that is reshaping supply chain and logistics. You will want to be here for what comes next.